Hi, I'm Hasmarkandaya Amirul from the College of Teacher Education of Zamboanga Polytechnic State University, presenting my demo teaching. Good morning, class. Please arrange your chairs and sit properly. Before we start our lesson for today, let us review first on the frequency distribution table. Class, have you ever experienced computing your grades? Have you ever experienced to determine your grades that you always encounter in your report cards? Do you know that we always encounter the three concepts of measures of central tendency? Why do we say so? You may have the answers for those questions from our lesson for today. Our lesson for today is measures of central tendency. Measures of central tendency has three concepts: the mean, median, and mode. First, we have the mean. Mean is the average of a set of data. It is the value equal to the sum of all the values in the data divided by the total element in the given data. Example number 1. Find the mean of all the grades of James in his engineering course if his grades are as follows: 90 for the mathematical analysis, 78 for the world literature, 92 for the discrete math, 89 for the calculus-based physics, and 96 for the engineering economy. Now, solution. Since we have 5 subjects, so our n is 1, 2, 3, 4, 5. And of course, for the x, we have the sum of 445. So we're going to use the formula mean is equal to the sum of x over n. Substitute. So 445 over n is equal to 89. So the mean of all the grades of James in his engineering course is 89. Example number 2. The results of the scores in mathematics test during the teacher's board examination are summarized by the table below. Find the mean of the scores of all the examinees. So we have two tables, the class interval and the class frequency. So how did we get the class frequency from the class interval? Like in the first table, 10 to 20. So it says that in the class frequency that there are 5 examinees who got the scores from 10 to 20, and 21 to 31 there are 10 examinees who got the scores. Solution. So let's construct a table of class interval, class frequency, class mark, and the f times x. So class interval, we have the same class frequency, and the sum of n is equal to 130. Then the class mark. How did we get the class mark? So to get the class mark, go back to the class interval. So just add the 2, like 10 plus 20 equals to 30 divided by 2 is equal to 15. So, and then also for the others, like 21 plus 31 is equal to 52, and then divided by 2, then 26. And then to get the fx, just multiply the class frequency and the class mark. So 5 times 15 is 75. 10 times 26 is equals to 260. And then get the sum of all the f times x. So we have 7,989. So, and then use the formula. Mean is equal to the sum of f times x all over n. So we have 7,989 over 130 is equal to 61.45. So for the mean of the score of all the examinees, we have 61.45. Let's proceed to the example number 3. The data shown are the scores in the statistics exam. Find the mean score of the 30 students if 9 class intervals shall be used in grouping the data. So we have the scores here of the 30 students. So solution. For the solution, we have step number 1. So first we have to determine the range. So to determine the range, just subtract the highest scores to the lowest scores. So we have 90 minus 47 is equal to 43, so the range is 43. And then next step number 2, determine the desired number of class interval. So it says in the problem that it requires 9 class intervals. So next step number 3, determine the class size. So to get the class size, just divide the range with the class intervals. So 43 divided by 9 is equal to 4.78, which gives us 5. So our class size is 5. And then now step number 2, construct and fill up the frequency distribution table. Step number 5, make the class intervals. Start with the lowest score until the highest score is reached. So note 47 is the lowest. This is the lowest value from the data, and then we have a class size 5. So 47 to 51, and then as we reach to the highest score, and then the table to be constructed is class interval, class frequency, class mark, and f times x. So next step number 6, determine the class boundary. Disregard this step since class boundary is not yet significant involving for the mean of group data. So step number 7, determine the class frequency. So determine the class frequency. So 47 to 51, go back to this course and count how many students got this course of 47 to 51, how many students got the scores of 52 to 56, how many students got the scores of 57 to 61, and then fill up the class frequency, and then we have 30. Next step number 8, determine the class mark. So the same, to get the class mark, add the 2 class interval and then divided by 2. So 47 plus 51 divided by 2, we have 49. 52 plus 56 divided by 2, we have 54, and so on for the others. And finally, the step number 9, determine the value of f times x per class interval. So multiply again the class frequency times the class mark. So 4 times 49, we have 196. 3 times 54, we have 162. And then add all the f times x and get its sum. So we have the sum of f times x is equal to 2031. So again, apply the formula. Mean is equal to the sum of f times x over n, and we have 2031 divided by 30, we have 67.7. Second is the median. Another important measure of central tendency is the median. Median is the value of the middle when all the elements in a set of data are arranged in ascending order. If the number of elements in a given set of data is odd, then there is exactly one element in the middle when the data is arrayed in ascending order. However, if there is even number in a set of data, there will be two elements to be considered in the middle so that the median for a set of data with even number of elements is equal to the average of the two middle elements. Let's have an example. So example number 1. Find the median of the measured height of all the athletes of YMA University given below. So we have 181, 211, 195, 189, 200, 206, 195, 188, and 189. So for the solution, we have step number 1. Identify the location of the median element using the given formula. Median is equal to n plus 1 all over 2, where n is the total of elements in a set of data. So m is equal to 9 plus 1 all over 2, so we have 5. Therefore, the fifth element is the median element of the given data. Step number 2, we have to arrange the data in ascending order. Step number 3, take the fifth element in the arrayed data as the median, as in step number 1. So, the median is 195. Example number 2. Find the median of the following raw data: 5, 11, 3, 6, 9, 11, 6, 12, 16, 4, 6, 10. So for the solution, identify the location of the data element using the given formula. So m is equal to m plus 1 all over 2, then substitute m is equal to 12 plus 1 all over 2 is equal to 6.5. Therefore, the 6th and the 7th elements are the median elements for the given data. Again, arrange data in ascending order in step number 2. Then step number 3. Take the average of the 6th and 7th elements in the array of data as the median. So, median is equal to 6 plus 9 all over 2 is equal to 7.5. Arranging the data in ascending order is only for ungrouped data, but this is no longer possible for grouped data. The frequency distribution table is now important in the calculation of median of grouped data. The median of a group data can be calculated using the formula. Median is equal to the lower class boundary of the median class plus class size multiplied by the quantity of n over 2 minus the less than cumulative frequency before the median class all over class frequency of the median class. How to get the median class? The median class is the class interval to which m is included with respect to the less than cumulative frequency. For group data, m is calculated by dividing the total number of frequencies by 2. Let us consider the given frequency distribution table below. Example number 1. So we have the table for class interval, class frequency, and less than cumulative frequency. So if you solve for m, class frequency, n over n divided by 2, so we have 65. Since m is 65, therefore the median class is the class interval 65 to 75. You follow? Since it includes elements 57 to 111 when arranged in ascending order, unlike class interval 54 to 64, which includes only elements 34 to 56. Now that we know our median class, we can now get the values needed for the formula of median for group data. So the class interval, class frequency, and less than cumulative frequency table in the frequency distribution table. Now look for the lower class boundary of the median class. So let's have a little recall. So the lower class boundary is equal to lower class limits minus 0.5. For the upper class boundary, it is the upper class limit plus 0.5. So lower class boundary of the median class, 65 minus 0.5 is equal to 64.5. That is our lower class boundary of the median class. So for the class size, upper class limit minus lower class limit plus 1. So we have 75 minus 65 plus 1 is equal to 11. So our class size is 11. So the less than cumulative frequency before the median class, by looking at the frequency distribution table, our less than cumulative frequency is 56. The median class frequency, so check our frequency distribution table, we have 55. Therefore, applying the formula median equal to the lower class boundary of the median class plus I multiplied by the quantity of n over 2 minus the less than cumulative frequency before the median class all over the median class frequency. So substitute 64.5 plus 11 times the quantity of 130 over 2 minus 56 all over 55, and we have is equal to 66.3. Example number 2. We have the table for class interval and class frequency. So now let's construct the table for less than cumulative frequency before the median class. So how to get the less than cumulative frequency? So write the first number and then just simply add to the second value of the class frequency. So 4 plus 3 we have 7, 7 plus 3 we have 10, 10 plus 4 we have 14, 14 plus 5 we have 19, then 19 plus 3 we have 22, 22 plus 3 we have 25, 25 plus 1 we have 26, and 26 plus 4 we have 30. So 30, it is the same with the class frequency, so check. If we solve for m, so m is equal to n over 2, which we have 30 over 2 is equal to 15. Since m is 15, therefore the median class is the class interval 67 to 71. So that's our median class. Now that we know our median class, we can now get the values needed for the formula of median for group data. So for our lower class boundary of the median class, we have 67 minus 0.5 is equal to 66.5. And for our class size, 71 minus 1 plus 1. Now 71 minus 67 plus 1 is equal to 5. And then for the less than cumulative frequency before the median class, we have 14. For our median class, we have 5. Now using the formula of the median, 66.5 plus 5 multiplied by the quantity of 30 over 2 minus 14 all over 5 is equal to 67.5. And for the last concept of the measures of central tendency, we have the mode. Mode is defined as the element in a set of data that has the most number of frequencies. In an ungrouped data, mode can be simply identified by inspection. Example number 1. What is the mode of the measured height of all the athletes of the YMA University given? So, given below, we have 181, 211, 195, 189, 200, 206, 195, 188, and 189. So, solution, we have step number 1. So, for the first step, we have to list down all the values and their corresponding frequencies. So, construct a table for the value and for the frequency. And we have 9 for the frequency. So, step number 2, take the value that has the highest frequency. Since 195 has 2 frequency and 189 is 2 frequency, our mode is 195 and 189. The mode of group data cannot be easily determined by just looking at the class frequency, since the values are grouped per class interval and the element inside the class interval cannot be directly determined. The mode of group data can be calculated using the given formula. So mode is equal to lower class boundary of the model class plus class size multiplied by the quantity of class frequency of the model class minus the class frequency of the class before the model class all over 2 times the class frequency of the model class minus the class frequency of the class after the model class minus the class frequency of the class before the model class. How to get the model class? The model class is the class interval with the highest class frequency. Let us consider the given frequency distribution table below. So we have the table for class interval and we have the table for the class frequency. Therefore, the model class is the class interval 65 to 75 since it has the highest frequency, which is 55. So for our lower class boundary of the model class, we have 65 minus 0.05 is equal to 64.5. For the class size, we have 70 minus 75 plus 1 is equal to 11. Class frequency of the model class, we have 55. And for the class frequency of the class after the model class, we have 7. And for the class frequency for the class before the model class, we have 23. So applying the formula, substitute, we have 64.5 plus 11 multiplied by the quantity of 55 minus 23 all over 2 times 55 minus 7 minus 3 is equal to 68.9. Example number 1. The data shown are the scores of 30 students in statistics exam. Find the median and the mode scores of the 30 students in 9 class intervals shall be used in grouping the data. So we have the scores of the students here. So solution, construct a table for class interval, class frequency, and less than cumulative frequency. Let's solve for the median. M is equal to 30 over 2, therefore the median class is 67 minus 71. For our lower class boundary, we have 66.5. For the class size, we have 5. And for the less than cumulative frequency, we have 14. And then the median class frequency is 5. So applying the formula, we get 67.5. Now let's solve for the mode. The model class is 67 to 71 since it has the highest frequency of 5. So lower class boundary, we have 66.5. Class size, we have 5. Model class, we have 5. The class frequency of the class after the model class, we have 3. The class frequency of the class before the model class, we have 4. So applying the formula, substitute. So 66.5 plus 5 multiplied by the quantity of 5 minus 4 all over 2 times 5 minus 3 minus 4, we have 68.17. Okay class, any questions from our discussion? Very well. Now let's have an exercise. Group your solves into 9. You have 10 minutes to collect data from your group mates. Ask these following questions and record the data. Are you done, class? Okay, now choose someone in your group to present your work. Okay, very good class, well done. Give yourselves a round of applause. Now class, go back to your seats, arrange your chairs. In a one whole sheet of paper, answer the following in about 20 minutes. Okay, you may now start. You still have 5 minutes more. Okay, time's up. Pass your paper to the center aisle. Forward. Now exchange. Then get one and pass. Let us check your work. Please put check by for the verification of the paper's owners. Now let's start answering. Count the scores. 5 points for each item. And then pass to the center aisle and then forward. And for your assignment, write the following. Are you done, class? I hope you learned something from today's discussion. That's all for today, but before I'll dismiss you, please pick up the pieces of papers under your chairs. Thank you. See you next meeting. You're dismissed.